And unit 3 in energy storage systems, ultra capacitors. And these are the contents. So capacitor. So ultra capacitor can also be called a supercapacitor. And history of supercapacitor, basic design of a supercapacitor, construction and working principle, and technologies used in the supercapacitor, and the substances used, charging and discharging time, features, comparisons, applications, advantages and disadvantages of a supercapacitor. So capacitor, so it is originally known as a condenser, is a passive two-terminal electrical component used to store energy in its electric field. So when a capacitor is attached across a battery, an electric field develops across the dielectric, causing positive charge to collect on one plate and negative charge to collect on the other plate. Supercapacitor is an electrochemical capacitor that has a very high energy density as compared to common capacitors, about 100 times greater. Supercapacitor is also known as electric double layer capacitor or ultra capacitor. So the capacitance range is from 100 farad to 5000 farad. So history of supercapacitors. In 1950s, General Electric engineers started experimenting components using porous carbon electrode for fuel cells and rechargeable batteries. In 1957, H. Becker developed a low voltage electrolytic capacitor with porous carbon electrodes. That capacitor came to known as supercapacitor as it stored very high amount of energy. So the basic design, electrochemical capacitors or supercapacitors consist of two electrodes separated by an ion permeable membrane as a separator and an electrolyte electrically connecting both electrodes. So when the voltage is applied, ions in the electrolyte form electric double layers of opposite polarity to the electrode's polarity. For example, positive electrodes will have a layer of negative ions and negative electrodes will have a layer of positive ions. And this is the example. Construction, supercapacitor are constructed with two metal foils each coated with an electrolyte material such as activated carbon. The electrodes are kept apart by an ion permeable membrane used as an insulator to protect the electrodes against short circuits. The construction is subsequently rolled or folded into a cylindrical or rectangular shape and is packed in an aluminum can. So this is the construction of supercapacitor. So this is positive electrode and this is negative electrode, and this black window is a separator, and this is the aluminum can which covers the supercapacitor, and we have positive pole and separator and carbon electrode collector, again carbon electrode and a negative pole. So working in a supercapacitor, there is no conventional dielectric. Both plates are soaked in an electrolyte and they separated by a very thin insulator. When the plates are charged, an opposite charge forms on either side of the separator, creating what's called an electric double layer. So this is why supercapacitors are often referred to as double layer capacitors. So this is activated carbon and we have electrolytes here, and this is the separator, again electrolyte and activated carbon. So double layers, and if the power comes here it will act as a electric double layer capacitor. So the electrochemical capacitor has two electrodes separated by a separator which are electrically connected to each other via the electrode. So when the voltage is applied and the plates are get charged, an opposite charge forms on either side of the separator, creating an electric double layer. So structure of EDLC. So this is porous carbon electrode. So anode and cathode both are porous carbon. So we have positive ions here and we have negative ions here. So we have a separator here. So in the positive ion there is a forming of negative layers. So absorbed ions and solvated ions. So we have negative ions here, we have positive ions here, on which the other layer is formed with negative ions in the cathode and positive ions in the anode. So this is the structure of electric double layer capacitor. So technology used, carbon nanotubes, carbon aerogels are used for supercapacitor plates or electrodes. So sodium perchlorate NaClO4 or lithium perchlorate LaClO4 are used as electrodes Polyacrylonitrile C3H3N, which is used as a separator, aluminum as a packing component. So why these substances are used? So electrodes, carbon nanotubes, highly porous, electrolyte, wide working temperature -90 degree to 400 degrees Celsius, non-flammable and low toxic, non-corrosive to the electrode and packing component, separator which has a unique tensile strength, electrical conductivity and not degraded easily. So charging and discharging time of different capacitors. Features stored a high amount of energy, have high capacitance, higher rate of charging and discharging, little degradation over thousands of cycles, low toxicity, high cycle efficiency about 95%. So comparison between capacitors. So electrostatic capacitor, normal capacitor, electrolytic and electrical double layer. So this is normal capacitor and this is secondary rechargeable capacitor and this is electrochemical double layer EDLC capacitor. Applications in startup mechanism for automobile used in diesel engine startup in membranes and tanks. So China is experimenting with a new form of electrical bus that runs without power lines but runs on the power stored in large supercapacitor which are quickly recharged whenever the electric bus stops at any bus stop and get fully charged in the terminus. A few prototypes were being tested in Shanghai in early 2005. In 2006, two commercial bus routes began to use supercapacitor buses. One of them is Route 11 in Shanghai. Backup power system in missile, power source for laptops, flash in cameras, and voltage stabilizer. So this is the bus operated on supercapacitor in Shanghai and installed in a bus. Supercapacitors installed in a bus. Advantages: high energy storage, wide working temperature, eco-friendly, quick recharging time, maximum life cycle, high cycle efficiency, high specific power, extremely low internal resistance, and it is safe. Disadvantages: low energy density, which holds 1 by 5 or 1 by 10 of a battery, cannot use a full energy spectrum for some applications. The voltage varies with the energy stored, have high self-discharge rate. Individual cells have low voltages, so series connections are needed to obtain higher voltages. Requires expert electronic control. Cannot be used in AC or high frequency circuit and it is high cost. So that is about unit 3 which deals with ultra capacitors or supercapacitors.